11. In experiment 11, we are using colligative properties. So based on the colligative properties, what are colligative properties? Colligative properties, those are properties that depends on the number of particles associated with that solution. So colligative properties, it could be boiling point elevation, freezing point depression, changing osmotic pressure. So these are some of the colligative properties, and it depends. Let's say you have the boiling point for water is 100 degrees Celsius. You add salt to it, the boiling point is going to increase. You add salt to water, freezing point is going to decrease. And you probably have experience, like if you want to make homemade ice cream, you add salt to the ice water, or you add salt to the ice mixture in order to provide lower temperature, or when they want to prevent like freezing of the road, they spread salt on the street. It lowers the freezing point. From the fact that how much is going to lower the freezing point, you can extrapolate, or you can use that information in order to find out what was the molar mass of that compound. That's the second method to measure experimentally molar mass of unknown sample. One was if the sample is volatile, you can change to gas and use the experimentation of the molar mass. The other one in this experiment is to use the freezing point depression for a compound that is soluble in our solvent. So we measure the freezing point for the solvent first, then we add solute to it, we add our unknown to it, and we measure the melting point again. The melting point or the freezing point, which is the same thing, is going to depress. So change in freezing point is directly related to number of particles. Number of particles, it depends on the mass, and it depends on molar mass. So the smaller the molar mass is, you get more number of particles, or is related. So when you are using your calculation, when you have the number of moles, then you can you have the mass of the unknown, you have the number of moles. Just like last experiment, you can calculate the molar mass. So if you're looking at the theory for this experiment, or theory or the background, basically it's talking about colligative property, which we talked already about it, and the vapor pressures and other properties, colligative properties. So what you do, you find the freezing point for the solvent, you find the freezing point for your solution. That means after you add the solute, the change in freezing point, delta TF, is going to help you to find the molar mass. The changing freezing point then is going to be used to find the molality. Lowercase m is molality, capital M is for molarity with the R. Molality, which is lowercase m, molality with the L, is number of moles of the solute per kilogram of the solvent. So we are going to find the freezing point for solvent, freezing point for solution. You subtract, you get the delta TF. Kf is a given number, is a constant, or molar freezing point depression constant, is a molar freezing point depression constant. This depends on the substance you are using. If you are using like benzophenone, this number is going to be 9.80. If you are using a different value, it's going to be different substance is going to be different value. For the purpose of this experiment, for benzophenone, we are using as the solvent. The value for Kf is 9.80 degree Celsius per mole. So you have the value for K, you find delta TF experimentally, you can calculate the molality. And because molality is, it can give you the number of moles, so you find the molality, then you use the molality to find number of moles, because molality times kilogram of solvent would give you number of moles. When you have the number of moles, then you can divide the mass by number of moles in order to get the molar mass. So the calculation here, it shows the steps for calculation is showing you have to exactly find the molar mass. But I also explained, because there are three formulas I'm using. These are TF and TI, final temperature, or the freezing point for solvent, freezing point for solution. So the two temperatures that you are getting by experiment, you find delta TF. KF is a given number, you find M, lowercase m. You find when you have the lowercase m, you plug in this formula. Because you have the kilogram of solvent experimentally, you find moles of the solute. When you have moles of the solute, molar mass equals mass over number of moles. So you have the number of moles, you can calculate the molar mass. So, but here are the steps for you, okay, for you to do the calculation. The setup is very similar to the setup for experiment 10, part B. We have the boiling water bath. We are going to heat up the sample to melt completely to change to liquid. Then we slowly let it cool down, and we record the temperature for freezing point by following the procedure. Okay, let me go ahead and start the procedure for this experiment. That is the major purpose or main purpose for this experiment, is for you to be able to collect your data. So I emphasize more on the procedure part of the experiment and the data collections, because if you are learning the experiments or you're taking the course by distance learning remotely, you are not here to perform the experiment to record those data. So those data is explained during the video, and you watch the video carefully, you record your data, then you can create the data sheet and submit